The spontaneous redox reaction between zinc metal and copper 2 ion can be harnessed in a voltaic cell to generate electricity. The cell consists of two half-cell compartments connected by an external circuit. Oxidation takes place in the anode compartment, in which a zinc electrode dips into a zinc nitrate solution. Electrons leave this compartment, travel through the external circuit, and enter the cathode compartment. There, reduction takes place at a copper electrode dipping into a copper nitrate solution. A salt bridge maintains charge neutrality in the two compartments. Let's zoom into the atomic scale and see how this cell operates. Here, at the anode, the site of oxidation, zinc atoms in the metal bar are in contact with the surrounding electrolyte solution. Each atom loses 2 electrons and becomes a zinc ion, which diffuses into the solution. The electrons given up enter the bar and join the flow of electrons up toward the external circuit. They travel through the wire and flow into the cathode, the site of reduction. When a copper 2 ion in the cathode solution makes contact with the copper electrode, it gains 2 electrons and is reduced to a copper atom, which deposits on the bar. Therefore, as the cell runs, the zinc anode becomes lighter and the copper cathode heavier. Now let's close in to see the role of the salt bridge. The non-reactive sodium and nitrate ions of the salt bridge prevent the buildup of charge that would occur as zinc ions enter the anode solution and copper 2 ions leave the cathode solution. Such a charge buildup would halt cell operation. In the anode compartment, nitrate ions leave the salt bridge to balance the gain of positive charge as zinc ions enter the solution. Some zinc ions also enter the salt bridge. In the cathode compartment, sodium ions leave the salt bridge and nitrate ions enter it to balance the loss of positive charge as copper 2 ions leave the solution and are reduced at the cathode. Thus, charge flows continually as the cell operates. Negative charge in the form of electrons flows from the anode through the external circuit to the cathode. As negative charge in the form of anions flows from the cathode compartment through the salt bridge to the anode compartment, positive charge in the form of cations flows in the opposite direction. The oxidation of zinc metal in the anode combines with the reduction of copper 2 ion in the cathode to give the overall cell reaction. Under standard conditions, this cell generates 1.10 volts of electricity.
Fuel cells have the power to change our world. At Ballard, we are dedicated to making fuel cell technology a reality, to replace the internal combustion engine in your car with a clean, quiet, pollution-free fuel cell engine. Fuel cell-powered cars look just like other cars on the road today, but they are cleaner, quieter, more efficient, and work very differently. When you turn the key, hydrogen and compressed air flow to the fuel cell module, which contains the fuel cell stack. A fuel cell engine consists of the proton exchange membrane, or PEM, fuel cell module, coupled with the systems required in a typical automotive engine. The electricity produced by the fuel cell is delivered to the electric drive system in the vehicle. The drive system converts electrical power into the mechanical energy that drives the wheels of the car. The fuel cell generates electricity that can be used to power a car, truck, bus, or other vehicle for as long as fuel is supplied. The fuel cell is 2 to 3 times more efficient than your gasoline engine and does not create pollution. Additional benefits include increased performance and onboard power, higher reliability, and greater flexibility in vehicle design and engine layout. But how does the fuel cell work? A single PEM fuel cell is made up of 2 plates, 2 electrodes, and 2 thin layers of platinum-based catalyst, separated by a plastic membrane, which, when fed with the fuel, reacts electrochemically to create electricity. Hydrogen from an onboard storage tank and oxygen from air are fed through channels on the plates. Hydrogen flows on one side of the membrane, air on the other. The catalyst splits the hydrogen molecule into protons and electrons. The protons can pass through the membrane. The electrons cannot, and have to pass through an external circuit, creating useful electricity. On the oxygen side of the membrane, the protons and the electrons react with oxygen from the air in the presence of a second catalyst layer, generating water and heat. By stacking together single cells, like slices in a loaf of bread, you make a fuel cell stack to produce the required amount of power. Just like your car, fuel cells need fuel to operate. The Ballard fuel cell uses hydrogen as a fuel, which can be produced in many different ways, and once produced can be stored as a compressed gas or liquid, or in a chemical or metal compound. Different areas of the world will create hydrogen in different ways, depending on economics and available resources. Hydrogen can be delivered to fueling stations by road, barge, rail, or pipeline, or can be made on-site at gas stations. People may one day be able to produce their own hydrogen at home. You can see there are many options available to enable the hydrogen infrastructure to grow. Fueling the vehicle is very similar to the way you refuel your vehicle today, but requires a special sealed connection before the hydrogen can be pumped into the vehicle's storage tanks. It only takes a few minutes to refuel a fuel cell car. And when fueled by hydrogen, a fuel cell emits water and heat and no pollution. Think what this means to the air around us. Now that you understand how the technology works in a fuel cell vehicle, you can look for them on our roads and ask yourself whether the vehicle you see is powered by Ballard.
That it would be untrue. You know that I would be a liar if I was to say to you, girl, we couldn't get much higher. Come on, baby, light my fire. Come on, baby, light my fire. Try to set the night on fire. The time to hesitate is through. The time to wallow in the mire. Try now, we can only lose, and our love become a funeral pyre. Come on, baby, light my fire.